I don't know who used that.
All right. The quiz over sections 4 through 7 will be on Tuesday of next week. For those of you that have been gone, or some of you I know tried those videos, I've got that fixed now. There was no sound for a couple of days. Those videos that are up there now do have sound. Well, I take it back. There was on the videos for November 7th. I don't think there was very many people gone for that one. I had a part 1 and a part 2. I don't have the original videos of those, so I think those are up there still, and I think those don't have sound. So, but that was 3 days ago, and I don't think there's anybody still needing that information. But the ones from November 8th on Tuesday, and then the one from yesterday is up there. Okay, and a lot of it was going over the homework, you know, so that might be the most of what you had questions on. If you were gone for those days, and you might have some questions on the homework, and I went over, especially yesterday, I went over in pretty great detail problems 25 through 30. Was it 25 through 36? So that is. I went through those in some detail, so if you had questions about those, you can sure look at that. Let's review this real quick. Yesterday we made this chart, and we said the connections between f and f prime. Another term I wanted you to understand is if you go from f down to f prime, that's the derivative. If you go, I said that, I think that I say this yesterday, if you go from f prime to f, antiderivative. Right? If f prime to f is the antiderivative, okay, which kind of makes sense. Now, I also noticed on a few people's papers as I was going around the room yesterday as you're working on homework and so forth, is I noticed some people writing capital F instead of lowercase f. Now, normally that wouldn't be a big deal, but it actually will be as we go forward, because we will use capital F to actually mean the antiderivative of lowercase f. Okay? In other words, it's easy to say, okay, well, the antiderivative of f prime is f, but what do you call the antiderivative of f? You know what I mean? And so we'll call that capital F. All right? And so so there will be a difference between a capital letter name of a function and a lowercase letter name. And so if you're used to writing capitals for that, just so you know. All right, so what we said here is if f prime is 0, and the chart, I think, is something you want to have committed to memory, or at least be able to generate, and I don't think it's very hard. If f prime is 0, what do you got on f?
Stationary point.
Stationary point, which means it could be either a local max, local min of f, or a flat spot of f. Okay, local max, local min, or a flat spot of f. If f prime is positive, f's increasing. If f prime is negative, f's decreasing. If f prime is increasing, f is concave up. If f prime is decreasing, f is concave down. So those were all of the connections that we wrote in a quick little summary. Then we also said that if you switch columns from here to here, that's the first derivative test for a max and a min. That is, if f prime switches from positive to negative, then f switches from increasing to decreasing. So that's a local max. And if f prime switches from negative to positive, then f switches from decreasing to increasing, which would be a local min. All right, so that was the first derivative test if we switch columns. If we switch these two columns, then we switch the concavity of f, which is an inflection point. So if f prime goes from increasing to decreasing, which is a local max of f prime, then you have an inflection point of f. And if f prime goes from decreasing to increasing, which is a local min of f prime, you have an inflection point of f. Okay, so switching columns here gives an inflection point on f. Okay, now somebody asked me this morning a really good question. Does the chart work both ways? Or those connections we wrote down, do they work both ways? We said if f prime is positive, then f is increasing. So as f is increasing, is f prime positive? And that's one of those little technicalities we talked about. Is it true to say because f is increasing that f prime is always positive? Could be 0, right? So if f is increasing, think of x cubed, it could go up, flatten, and then keep going up. We say that that graph is always increasing because it never decreases. But it does flatten for just a second. So its slopes are positive everywhere except that flat spot where it's 0. Okay? So it's mostly true. If f is increasing, then the slopes are positive, but it could flatten just for an instant. Okay? All right, so that's a nice summary of the things that we have so far. So the big thing today, I think, is sketching these graphs. Being able to take this information and be able to sketch an f prime graph and be able to sketch an f graph. Because that really makes you think through the connections. All right, and I know that's some of the parts that you struggled with probably on some of these. So let's go through in the homework 37 through 45. We've got this picture. Oh, whoops. Give me a second. All right, we've got this picture right here for 37 through 45. I believe that's the right one, isn't it? Okay, and they are going to ask us several questions about this. Now, this is really the main focus on our next quiz. Is this kind of a thing? Here's a graph, or maybe like 50 and 52 and 48, those where I give you an equation and you use your calculator. Now, I haven't decided yet. There's a possibility that the quiz will be all no calculator. Okay? So if it is, then obviously I wouldn't give you any of these equations. Unless I gave you just a real simple type equation that you should be able to graph yourself if you want to look at a graph. We'll do one of those tomorrow, like a parabola or a line or something like that. Something fairly simple that you could handle yourself without a calculator. And we'll talk about that tomorrow. Okay? But otherwise, it'll be, here's a graph. It's either the f or it's the f prime, or today we're going to talk about f double prime, and then you answer these questions. All right. So, 37. Where is f increasing? Where is f increasing? This is a graph of what right here, by the way? This graph is f prime, isn't it? You have to read the directions really carefully. On this quiz, I think I mentioned this yesterday, you get off track on a series of problems like 37 through 45 and you miss the whole bunch. You got to read the directions. It says it's the derivative of f, I think, in the directions. So this is the f prime graph. In an earlier set of problems, we had the f graph. You know, so you really got to remember which one you're looking at here. Okay, so on 37, it says, where is f increasing? Well, where are we looking on this? Where it's above the x-axis. Positive. Are we okay, though, if it touches into 0 here? We're okay there. So they say, where's f increasing? So it would be all the way from -3 to 4. Now, you wouldn't say infinity here necessarily because they've given you this kind of boxed-in picture and they didn't put arrows at the end and so forth. Now, on the quiz, if you said -3 to infinity, you know, I probably wouldn't count that wrong, but I'll probably try to be very clear in the directions about that. Okay? 38. And these are the x intervals we're talking about here. Where is f decreasing? Well, that's going to be from -4 to -3. That's this part back here where the graph f prime is below the x-axis. Where f prime is negative is when f is decreasing. So if you got this chart in front of you, it's very helpful. Where does f have stationary points? X equals -3 and 3. That's how that answer should look. Don't write the ordered pair -3, 0, and 3, 0. That's not what we want because that's not a point on F. That's the point on F prime. They just say, where is the stationary points? Give the X values. Now, that's something that as you guys go, as we go forward in these problems, and oftentimes you're given the derivative graph. You're given an F prime graph. You will, pun intended, zero in. I really think the first places you'll tend to look on these graphs, you'll get in the habit of just looking right at that x-axis. Because that is your stationary point from the chart right there. And that's where all the interesting stuff happens. Okay? And so you'll be looking at this and you'll say, all right, this is where it changes from negative to positive. That's that crossing the columns thing I talked about earlier. Okay, right here it goes positive and stays positive. Okay, what's that going to be on the F graph? It's going to be a flat spot, isn't it? That F graph is going to be increasing, and then it's going to flatten, and then it's going to keep increasing. Okay? All right. Anyway, stationary points. 40. Where are the local max points? None. What do you need to have a local max? F prime's got to go positive to negative. That way F can go increasing to decreasing. That graph never goes positive to negative. So there's no local max points. Yeah, and I know some of you are going, wait, there's a local max right there. Yeah, that's a local max of F prime, but it's not a local max of F. Okay? And so that's where we got to be clear about that. Local min. X equals -3 because F prime goes from negative to positive, so F goes from decreasing to increasing, which is a local min. Okay? 42. Is F concave up at X equals 2? X equals 2 is right in here somewhere. If you got the chart in front of you, F is concave up if F prime is increasing. Okay? Since, is F prime increasing right there? It's going down. So the answer is no, and you'd say because F prime is decreasing, not increasing. Okay? Where does F have points of inflection? -1 and 3. And again, you will soon, come to memorize, I think, that inflection points of F are going to be at local max and mins of F prime, and that comes from this right here. If F prime switches from going up to down or down to up, and that's a local max or min, then you've got concave up, concave down changing, and so that's why those are inflection points. 44, find the equation of the tangent line. Okay, 44 and 45 are kind of the same thing. Whenever you want a tangent line, you go y equals, you need the slope, you need a point. Okay, what did they tell us there? They told us f of -3 was 2. So that's the point we needed. So we put in the -3 and the 2. And here we need the slope at -3. So we just read, what is it? Oh, 0. Well, that's going to wipe out the whole parenthesis. You get y equals 2. Now, it's not even important that you simplified that. I actually would even let you leave that. That's fine. But y equals 2, which is a horizontal line, which makes sense, right? If the slope is 0, -3 is where we said there was a local minimum. It should have a horizontal tangent line. So the tangent line would be y equals 2. Okay? All right, 45 is the same thing. Let's take a look at those graphs then. Now, I went ahead here. I was going to look at 48 and I was going to look at 52. Now, the difference here is 48 is a graph of F. Now, I went into my calculator. I wanted to show you a couple things on your calculators here. So if you want to do this along with me. Just in playing around here, I found a couple things. Now, when I look at these graphs, and you may not have done 2 at a time, but there's a couple things you can do if you want to graph more than one thing at a time, but you don't want to look at both of them at the same time. Okay? And the other thing I've noticed on this is when I look at these two graphs, I see a whole lot of empty space up here on the y-axis and down here below. And so here's where it really is helpful to do some manual settings on your graph, because I don't think they gave you a domain, did they, to look at? Yeah, they never gave you a domain to look at. So if I was going to work with this problem, I'd want to do a couple things. First of all, let's just look at number 40. Oh, shoot. Yeah, one of those we don't even need. I looked at the wrong problem. We don't even need this one. Did we do that one at all?
No.
That's 47. Okay. All right, so let's get that one out of there. All right, so this is 48 and also 50. It's also 52, isn't it? Okay, but one's F and one's F prime. Okay, so I got all this extra space. So go into your window, go into your settings, and manually change the Y to say -1 and 1. It really is helpful if you do that, because then you get a graph that looks a little bit reasonable. Now there's another thing you can do that's kind of neat, and whenever the axes highlight like this, whenever you move your whenever you move that hand over the axes and it says that, if you hold down and drag up or down or left or right, you can kind of just manually zoom that graph, which is kind of nice sometimes too. So like what I want to see on this one is, first of all, what's happening way out to the left and way out to the right. It looks like it's a horizontal asymptote. Now, as we're going to learn, and I think you might have done a little bit of this in trig last year, I don't know for sure, but if you look at this function, okay, if you look at this function right here, okay, I don't know why that's blinking, thank you. If you look at this function, as x gets really big, what happens to the top compared to the bottom? When x gets really big, the bottom gets a lot bigger than the top, right? And anytime that happens in a fraction, what's the fraction do? It gets smaller, right? When the bottom gets a lot bigger than the top, and we're going to talk a lot about that in the next chapter with when we do limits and stuff. But I think in Algebra 2 you looked at in behavior a little bit of these graphs. And the bottom's going to get much bigger, so that fraction is going to get very small, go towards 0. So it makes sense. I guess what I was interested in is there ever going to be any times, before I answer these questions, is there going to be any times way out here where, that graph goes back down below the x-axis and stuff like that? And I don't think it is. And they're just going to be max and min, or they're just going to be horizontal asymptotes. So I'm just going to zoom to about there. And now we'll look at this. Okay, quit it. All right. Now, let's look at 48 now. How many roots does f prime have, and where are they located? Now, remember, this is the f graph. So how many roots does f prime have? We're going to put that in red. Well, a root of f prime means what? Where it crosses the x-axis, meaning 0, right? So a root of f prime would be that'd be this in the chart, right? So on f, it would be a stationary point, local max, min, or flat spot. Well, how many of those do we have? 2. Looks like there's one there and somewhere up here. And I suppose I can trace, right? That's the nice thing about the calculator. It traces, it'll take it right to you. And for now, that's good enough. Now, later on, we'll have to, if I ask where is the local max and min or whatever on that, there'll be some calculus things we'll have to go through to do it. But for right now, we can just trace and find those spots. Okay? So you can find those. Where is f prime positive? Well, I'd be looking where this graph is increasing. Well, that's from whatever you had for this point to whatever this point was, right? That's this region right through here. Okay? Is f prime increasing at 2? Where's 2 at? Somewhere in here? Somewhere in there. Is f prime increasing? Again, the chart says it. Is f prime increasing is when f is concave up. Is it concave up there? No. All right, and then the part that we probably really need to talk about is the sketch of f prime. So if I want to come in here and graph f prime, what would I be thinking about? Well, I'm looking at that f graph, and over here in the beginning, this f graph is decreasing, and what else? Concave down. So that f graph is decreasing and concave down, which means the graph I'm going to draw has got to be negative and decreasing. So I've got to add, now where is it? We can tell where it is by what these slopes are, right? These slopes, this graph's going down, but it's barely going down, right? So my y value should be pretty small, right? My slope. But it's getting steeper, right? So I should have, so I don't know where it is. I mean, let's say it's right in here, and it's coming down. Now it doesn't necessarily follow this, okay? But it needs to be decreasing and below the x-axis. Okay, now where's it going to switch doing that? Somewhere about here, there's an inflection point where this thing switches to concave up. So my graph will have to still be below the x-axis, but it'll have to start increasing. So I've got a graph that's coming down like so, and at some point, in here, I don't know how that's coming down, it doesn't really matter. Some point this has got to start increasing. Now this is going to stay concave up till, I don't know, right in here. So that means this graph's got to keep increasing. No, wait a minute, I'm missing something.
It should cross zero. Cross zero.
It's got to cross zero right here, because what are my slopes right here? Zero. So this thing's got to come up and cross like that, right? Because in this neighborhood, right here, my graph is going down and is concave up. So going down and concave up means my f prime graph should still be negative, but it should be increasing. Now right here, I get a zero slope, so I should be there. Okay, now my graph is increasing and concave up. Increasing and concave up. So I need a graph that's positive above the x-axis and increasing. So that's going to happen like so. Whoops. Till right in here. Now what do I have? Till about there. I've got increasing and concave down. Increasing and concave down. So now I got to have a graph that's positive but starting to decrease. So right here, I've got to have, dang it. All right. So right at this point, I've got to be back to zero. So here I've got, starts going down. Okay, so I get to here. Okay, that matches up with that. And now it's got to come down there, sort of. Okay? All right. And now what? The rest of the way, I've got f decreasing, and what's the concavity of it? Well, actually, there's going to be a switch here at some point. Probably can't see it yet. This is concave down right now because we said this is a max, but it has to switch to, it's really kind of a tricky one to see because what you have is that graph coming down, and then it's going to switch and then ride right along the y-axis. So there's got to be an inflection point in there. It might not be there. It might be farther out. Okay? So the concavity is going to switch. So I think this is going to come down, have an inflection point, or have a local minimum, kind of like this, and then come up. But it's going to stay negative because this graph is going to keep decreasing. But I do have to have a little bit of a local minimum kind of there at the end, towards the end. Okay? And that's kind of a tough one because that change in concavity is very slight. But local maxes and mins, notice, let me mark them with an X here. The local max and mins of f prime should match my inflection points. Local max mins of f prime should match my inflection points of f. And sure enough, there it is, there it is, there it is. My zeros should match my local max and mins. Here I go from negative to positive, that's a local min. Here my graph goes from positive, my red graph goes positive to negative, I got a local max. Okay, so all those things in the chart are in there. Okay, Now, let's go to 52. This graph is now what? The green graph is now f prime. Okay, the green graph is now f prime. So now my red graph is going to be f. All right? So part A says, where is f increasing? Where's f increasing? Well, where this one is positive. What's this point right here? Is that 2?
Yeah.
It's exactly 2. So from 2 to infinity. Okay? Where does f have stationary points? Well, that would be at this local max and at this local min. Right? No. This is the f prime graph. I'm just testing you. There's a lot of stuff here, isn't there? I mean, you really got to you got to double check yourself when you do one of these. You say, okay, again, you don't want to outsmart yourself. Sometimes your first thought's the best one, but this might be one of those times where you think, okay, now do I have that right? Okay, it wants to know where f has stationary points. That's when f prime is 0. This is the f prime graph, so that's the only one. X equals 2. Okay? Where does f have local minimums? That's the one. It goes from negative to positive. Well, that's nice. Okay, that's a local minimum. Where is f concave down? F is concave down whenever f prime is decreasing. That would be all the way to here, right? And would it be past this one? Right? So that would be, I don't know, what are those points? Help me out. From negative infinity, that's negative 1. And then from, this max is at 5. From 5 to infinity, right? Because f is going to be concave down whenever f prime, the green graph, is decreasing. All right? And then E says to sketch the graph of f. So in red, let's sketch the graph of f. So what I would be looking at, since this is the f prime graph, I'm looking at the green graph there, and I'm saying, okay, it's negative, and it's decreasing. I don't care now that it's concave up or concave down, because I'm looking at the f prime row. So f prime is negative and decreasing, so the graph I'm going to draw has got to be going down and concave down. Now, where do I start it? It doesn't matter. Remember we said yesterday? Yeah, if we're going from f prime to f, we have an infinite vertical shift of graphs that could work, because this green graph is just the slopes of f. Any graph you just shift up and down, you don't change its slopes. Okay, so we can start anywhere. So I'm going to start it up higher here just to stay out of the way. So I got a graph that's got to be decreasing and concave down until here, right? So it's going to be, oops, decrease, something like that. Now this graph switches negative and increasing. So between these 2 points, I've got negative and increasing. So my graph's got to go down, but be concave up. So I've got to switch to concave up until here. Now, didn't we say that was going to be a local minimum?
Yeah.
Earlier in that question, we said we should have a local minimum there. And sure enough, we do. Okay? Now my graph has switched to positive and increasing until 5 there. So positive and increasing, my graph should be going up and be concave up. So something like that. Now my graph is positive but decreasing. So my graph should still be going up but switches to concave down. And it should keep doing that the rest of the time. Still, it should be going up but stay concave down, kind of like the natural log graph that would just continue on. Okay? miss anything there? Because we don't care about these inflection points on F prime, right? We don't care about the change in concavity of F prime because you look at the F prime row and we don't have concavity in there anywhere. Doesn't matter to us. Okay. And then 54 with just some matching of those graphs, and I guess we could see if you got them right real quick. 54, A matches with which? A matches with Roman numeral 3. B matches with 5. C, 2. D, 1. E, 4. Okay. Those of you that are going for that matching activity we did with graphs, you can do that sometime if you still would like to. All right, let's move along here. Let's go to the book and page 64.
Now.
All right. What I want to do here now is I want to add to our chart, okay? Because what we're going to talk about here in section 7 is the second derivative, F double prime. Now, first thing I'm going to do is erase. If you want to redraw your chart, that's fine. I'm going to erase this stuff I put at the bottom because I need to add a third row, okay, for F double prime. Now let's do this the easy way. I mean, when I listed those connections the other day, I asked you what would be the relationship between F prime and F double prime? And the answer was what? The same as F and F prime. So let's do that first. Let's just look at the bottom two rows. Is there anything we can fill in here? Increasing, decreasing, the derivative is positive, negative, so right here we would have this automatically, right? When F prime is increasing, F double prime has to be positive, and when F prime is decreasing, F double prime has to be negative, right? Now what about these blank ones over here? Is there any significance if F prime is below the x-axis? Does that tell you anything about its slopes? Not really. The fact that it's below the x-axis doesn't tell you anything about its slopes. The fact it's above the x-axis doesn't tell you anything about slopes. And the fact that the F prime graph goes through the x-axis doesn't tell you anything about its slopes. So those are going to be empty. They're not going to have any relationship at all. But now, notice what we just learned, though, all of a sudden, just by doing that, is if we go from the F row to the F double prime row, we've just realized that when F double prime is positive, that F is concave up. And when F double prime is negative, F is concave down. And that is a very important thing to think about. Probably the most important use of F double prime is concavity. F double prime determines concavity of F. So as we move along here, and you see something with F double prime, and it's referring to F, you ought to be focused in on concavity. F prime talks about slopes. F prime talks about how steep a graph is going up or going down. F double prime talks about how much it's curving. Like, if you had a graph that had a slope of 3 and compared it to a graph that had a slope of 5, you would know 5 means it's steeper than the one that's 3. But if you have one that's got a second derivative of 5 compared to a second derivative of 3, that means that graph is curvier. There's probably a technical term, but I don't know what it is. More concave. Okay? More concave up or more concave down. But that is very true. I mean, some of you have already made the connection based on that matching activity. If you have a parabola, then its derivative is going to be a line. What that means is the curviness of a parabola is a steady increase. So therefore, its slopes go in a line. But not all curves have that. Okay? A lot of curves, their derivative is also curved. Okay? Because their concavity is different than a parabola is. Okay? It's not true to say that a cubic like this is like two parabolas connected together. It's not. The curvature of those is different than it is for a parabola. Okay? All right. So F double prime, probably the most important thing we come away from today is F double prime determines concavity. Well, that's also going to help us with the inflection point then. So let's add another column on here. Okay? Because of our F prime thing here, you know, F double prime could be positive, could be negative. F double prime could also be 0. Well, what should that be on F prime? That should be a stationary point. And as we know, that's either a local max, local min, or a flat spot. Now, two of those make an inflection point, right? So we might be tempted to say that when the second derivative is 0, we have an inflection point. But that's not true. To have an inflection point, we have to switch columns. We have to switch concavity. So F double prime has to switch from positive to negative or negative to positive. Well, that usually happens at 0. But it is positive. Think of a graph of F double prime now. An F double prime graph could be positive, then hit 0, and then go back up to positive again. So you have concave up, and then staying concave up. No switching concavity, so you don't have an inflection point. So F double prime, we're going to say, is a possible inflection point. Now it's going to help us later on when we get to equations. If we want to find an inflection point, we'll take the second derivative and set it equal to 0. But then we'll have to check and make sure there's a change of concavity there. So these two are inflection points, okay? If you have a local max or a local min of F prime, and we've already seen that in the earlier graph. If we have a local max or min of F prime, we do have an inflection point of F. Because there will be a change in concavity. But it's this flat spot that causes us to have to say possible inflection point here. Okay? All right. And then we could extend this. I mean, because if we think of our F double prime row as like our F prime row, we could come out here and we could say, okay, F double prime is increasing, then F prime would be concave up. But the fact that F prime's concave up doesn't really tell us anything about F. So I'm not even going to add that row. I mean, we know that because F double prime and F prime have that same relationship. Okay? So if I was being asked a question about that, I would just look at the rows we already have. So I would say we just stop with the chart right here. Okay? So notice F double prime mostly tells us about concavity and inflection points of F. Of course, F double prime does tell us all that other stuff about F prime, but that's just the same relationship we've already been working on for what seems like forever. Okay? All for like 4 days or whatever. All right. So let's take a look at this. Let's take a look at this picture from yesterday. Okay? All right. If I take this, now remember here the blue graph is F. The green graph was F prime. So now, let's think about F double prime. Now, first let's ignore the blue. All right? And let's just look at the green as F prime. And now we're going to think of F double prime. Now, what's the connection again between F prime and F double prime? It's slope, right? It's same as F and F prime. So the F double prime, which is going to be in pink or purple, the purple is going to be the slopes of the green. Right? Everybody get that in your head now? The purple is going to be the slopes of the green. So think about this now. As I move along, where should the purple point come in at here?
Really high.
It should be up high above the x-axis. Because right now the green graph has positive slopes. Big positive slopes. So the green graph has big positive slopes. See how it's 15 is its value? So it should be way up high, coming in anytime now. Anytime now. Oh, let's get rid of that point. Oh, yeah, I got it. It should be. Wait a minute.
You grab wait, to the right.
So I need to.
You're going to click show it.
Click show it.
Well,
To the right. To the right.
no, that's the graph. I don't want the graph. I got the point. Okay, hang on here a second.
Hey, you showed the green graph.
Yeah, now the green graph disappeared. I wanted that, but I want to hide that point. There we go. All right, so right through here, and let's hide that. We don't, oh, whoops! I got to show X. Darn it! I want to.
Yeah.
Okay, so right through. Okay, here it comes. All right, so right in here, I'm on the green graph here now, right? Ignore the blue. Ignore the blue. I'm on the green graph. This is positive slopes. My graph only goes up to about 2.5 here, so not until the pink values got under there did it show up. So it was way up high, okay? Positive, but getting less positive, right? Several people have been coming in for help and been talking a lot about that, and that makes a lot of sense. These slopes are positive, but getting less positive. So therefore, the pink point is getting less positive. It's coming down, all right? Now that makes sense because the green graph is not only increasing, but what else is the green graph? It's concave down. So right now, my F prime, I'm looking at F prime and F double prime. Remember, that's the same relationship as F and F prime. So my green graph is increasing and concave down. So the purple graph should be above the x-axis, but decreasing. Okay? All right, so here it comes. Now all of a sudden the green graph has a slope of 0. It's a local max, so the purple is going from positive to negative. Now the green graph is going down right through here. Okay, still going down, still going down. And then I have an inflection point right there on the green. So therefore I've got a local minimum down here. Still going down, so the purple point is still negative. Right here I got a 0 slope. Keep going, now I got positive slopes that continue on. So if I look at the purple graph and the green graph, those have an F prime relationship. Same thing we've been talking about. Now let's hide the green one. Okay, now let's just talk about the blue and the purple. Or pink, I can't decide. I can't make up my mind which one it is. Okay, magenta. All right, now I'm just looking at F and F double prime. And we said that F double prime mostly tells us concavity. So sure enough, right through here, when F double prime is above the x-axis, right in here, this graph is always concave up. Right there, when F double prime is 0, When F double prime is 0, I've got my inflection point on F. Now, as F double prime goes negative, this is switched to concave down. Concave down, all the way until there. I have another inflection point. It's also a flat spot. But that doesn't really matter. It's just the fact that it's an inflection point. And now the purple graph or the magenta graph goes to positive. I switch back to concave up. So concave up, concave down, concave up. Purple graph should be positive, negative, positive. Okay? So not as many connections between F double prime and F. All right? So there's really 3 different kind of things we can have. We can have F connected to F prime. We can have F prime connected to F double prime, but those are really the same. And then we got F and F double prime, okay, which is mostly just concave. All right, take your calculators out and turn to page 70. All right, make sure your calculator's turned on and you're ready to receive this here. Now, okay, everybody getting that? Now let me see if I have a picture of this. Not sure I do. Yeah, I got one of them, I think, anyway. 26. I got 26.
Is it a quick poll?
Quick poll. Yep. Quick poll. You're bad. It's 'cause you're bad. All right. Now, what you're supposed to do here is you're supposed to identify in the directions. It says on page 70. Okay. This is another question that's probably going to be on the quiz next week. You got 3 graphs. One of them is F. One of them is F prime. And one of them is F double prime. Tell me, type in your answer in that order. So if you think that B is F, then you'd put B first in your answer. If you think A is F prime, then put that next. And C, F double prime, then you put B, A, C. Okay, is what you type in and submit for your poll. Okay, F, F prime, F double prime in that order.
Found it.
Just put them in with no commas or anything, and put them in lowercase is fine. Just put lowercase without commas, just A, B, C, CBA, whatever. What? Okay, make sure and go up and submit. All right. Let's. A lot of people have submitted their answers here. We had two that were the most popular. Two different answers that were the most popular. Now, what this does is really makes you, again, like I said, zero in. I think is a good place to start. I think when I'm asking a question like this, I'm going to look at the x-axis first, right? Because stationary points. Think about your chart here, and on the chart at 0. Right, is where you have stationary points. Now, since we brought f double prime into the picture, we've got two possibilities there. So if I come in here and look at this 0, and I notice it goes positive to negative at a local max, right away, that makes me think that f prime would be a possibility, but also this could be f prime where the max is and f double prime here, right? So you don't have to find all the connections, but if you can find one like this, then you can go in here and say, okay, now at this, let's see, I was on that dashed one. I don't get another 0 of that one. So what if I was doing this, then I would go to the f double prime and see if the concavity matches. So looking at the black one that I wrote, if this one is f double prime, then right through here where it is positive, that would make this graph have to be f, right? Well, when f double prime is positive, f has to be concave up. So the whole time till here is f look concave up. Kind of does. Then this graph goes negative, this seems to go concave down. So that matches up pretty good. Now sometimes you got to be careful because some of these are kind of tricky. So before I probably said that as my answer, so that would make my answer what? C, B, A, right? Now before I would answer that though, I would probably double check and make sure that the red couldn't actually work as well. So is there any problem with the red? Well, if the red was what I said it was, then this would be f double prime. Well, f double prime is down here negative the whole time, which means my f would have to be concave down the whole time, right? Well, this was the red f I had. Is it concave down the whole time? Doesn't seem to be. Seems to switch to concave up over here. So the red, which would have went B, A, C, doesn't seem to work. So, how do we do?
What?
So BAC, should we see who that was?
Yeah.
Who are those? BAC's the wrong one, isn't it?
Yes!
Shame, shame, shame. CBA, where's some, is there any other CBAs over here? Might have.
People put spaces.
Oh, there's a CBA with commas in it. CBA.
CBB.
What was that?
I think it's like
That's bad. All right. Let's stop that. And let's.
I can redeem myself.
We'll do another one. Let's do 27. Now I don't have 27, unfortunately, to display up here, so you have to look in your book.
Yeah, I already.
Okay. On page 70, let's try 27. Again, look for those zeros. Try to find an F prime relationship that could also be an F prime F double prime, and then use the second derivative with concavity to maybe disprove it.
Please.
Hey, you can still do it, Jacob. Okay, you just won't be able to submit it, right? Write it down in your paper. Okay, it's in your book, problem 27. All right. Now, go ahead and if you've got now, I apologize, I don't have the colors here, so kind of look in your book, and this drawing's not really great. But what I would probably notice first was the C graph, because it looks like it's got quite a few zeros here that may just match up with the A graph, I believe. Right here, this goes negative to positive, which would match up with that minimum. So that would be the C graph being F prime and the A graph being F, I believe, right? Here it switches positive to negative, which matches up with that max, I think. Let me know here if I'm off on something. That goes to negative to positive, which would match up with this minimum. And then right here, positive to negative. I'm sorry, this minimum right here. And then positive to negative, which would be that maximum.
Yeah.
Okay? But that could also be an F double prime and F prime like this. No, F prime. Said F prime. Did you erase it?
Oh, okay.
Oh!
Register.
Ah!
What did you do?
Over farther left. Left.
Left.
No, open the marker, like the marker board.
Oh, well.
Just rub it around and make it.
Listen, whoever Jack can fend for himself. All right, so
It's
yeah.
it's directly in the left
F.
part of the chart.
Okay.
The far right part of the chart.
So F prime. Now, if we look at, see, sometimes when you get the cap on, it's still buzzing. You set it in here. It's all right. So let's look at B to disprove. So on the red, B would have to be F double prime. Okay? So the B graph is, and then the F graph, or A would be the F graph. So B is negative down here. The A graph would have to be what? Since B is negative this whole time, the A graph, which I thought was F, would have to be concave down. It's not. Very easy to see. So it looks like the blue connection is the one, which would make that F. So we should have B, A, C for our answer. And let's see how we do.
Yeah. No. No.
Okay, Mr. Clark.
19.
Two people put
Do I even need to look? Do I? Seriously? You don't know who it is? You just want to see it for sure. There we go. All right. All right. Bonus points. Back of the room.
Who took my calculator?
You told somebody got your login, your password. Protect those passwords. All right. Last thing. On your paper, just in your notes, okay, that right there is an F prime graph. I want you to draw the F graph. They tell you that the 0 of F is 0.
So it starts with the origin.
Okay? In other words, they tell you F of 0 is 0. That's F prime. Draw yourself, just in your notes, a quick sketch of the F graph. Now, since it starts at the origin, it might be helpful to go to the right first since we have a starting point. So what am I looking at? This black one is F prime now. Okay, the black graph is F prime. What am I looking at? What do I care about this part here? That it's negative. And again, looking at the chart, I care that F prime is negative and decreasing. So the graph I want to draw is going down and is concave down. Right? So it's got to be going something like that.
Wow.
It's got to be going down, it's got to be concave down. What about this part over here?
Going down positive.
I care that this is negative which means my graph's going down, but it's increasing, so concave up. So it's coming in here, kind of like an inverse x cubed or something. Coming down here, concave up, flattens, and then goes down like that. Right? Good. Homework. Section 1.7. Take out your assignment sheets. We're going to split this into 2 days. I've got some to add the next day, so it's mostly what you see there in front of you. 4 through 8, 14, 15 through 22. Now what they're going to ask you in some of these is going to be kind of an F double prime to F relationship, and some might be an F prime to F double prime, which really is just review from last section because it's the same connection. Okay, 15 to 22, number 25. We already did 27. So we don't need to do that one. And then 43, 44 we'll save till tomorrow. So just those right there. Okay? Is there anybody that knows they'll be gone tomorrow? Okay? Tomorrow, Austin is going to be this. Okay, that's going to be tomorrow. And Austin, there might be some of those review, Austin, some of the review exercises are listed at the bottom. I may throw some of those on. I'll post it on the website. Okay, so you might double check that. So that'll be tomorrow. I know David and Harry will probably want to work ahead, so they'll probably do those anyway. Have your weekend free then.
Wait, were you in the class?
I can't trust your disagreement because you're loud.
When they were forming?
But if exaggerated, I know that it's exaggeration, but it's hard.